Hello, ladies and gentlemen, and welcome back from break. I am very happy to see you. I hope you had a wonderful break. I know I did. As always, I'm looking for memes. So instead of continuing where we left off, I decided we're going to start a new section. Not just any section, my favorite section. Organic chemistry was the class that was the hardest for me in college because my high school teacher never showed me what it meant. And I think I'm going to make it easier for you. So the beginning of that class should be easy if you have to take it. But anyway, I'm looking at chapter 18, and that's where I'm getting my notes. So if you like following along, feel free to. It would very much help you if you read through this section, but I can't force you to do that. So, organic chemistry. What the heck is that talking about? Well, thinking outside the chemistry box, organic just means alive, right? So a rock is not organic, but a tree is. So organic chemistry is the study of things that are organic. And how they are made up of chemicals. Yay, interesting. But the sciencey definition I got to give you is it's the study of organic compounds. Okay, and these are notes. Organic chemistry is the study of organic compounds. Now, what the heck is an organic compound? An organic compound is a covalently bonded carbon compound. So we got some layers of definitions here. So organic chemistry is the study of organic compounds. And an organic compound is a covalently bonded carbon compound. In other words, CH bonds. So carbon with hydrogen mixed together. I wrote C-H. I don't know the notation you guys learned for bonds, but I'm going to be reviewing that in just a second. So organic chemistry is the study of organic compounds, which is covalently bonded carbon compounds, which are CH bonds. Now reminder, what is covalently bonded means? That means you're sharing electron pairs, okay? In other words, let's say you had a little H friend, right? How many electrons does an H have? Just one. Let's say you have a C friend. He's got 4 electrons. He's really stable. Let's say you have another H friend right here, and another H friend here, and another H friend here. Looks like that C's about to get mugged, right? Well, not really. They're actually just going to share. They're going to have a good time. So these electrons sort of magnet together on all 4 sides. And so what this ends up creating is an H. We got a pair there. We got a pair there, a pair there, and a pair there. So this is completely stable because it's got an octet. It's got 8 electrons. This is why CH is such a stable bond, which is cool that God created things that are alive out of one of the most stable bonds to exist. He wanted to make sure we were made right. When we have an electron pair like that with just 2 electrons, how we draw that is with a dash. So H connected with 4, I'm sorry, C connected with 4 H's with dashes, okay? So this is what that means, and this is what that means. So to summarize, this is a covalent bond. These covalent bonds make up carbon compounds, and those carbon compounds are also organic compounds. And those organic compounds are what organic chemistry is all about. Pause the video if you needed to write any of this stuff down. What is organic chemistry not? Organic chemistry is not any of these 3 things. A carbonate, which is a CO3, and that has a -2 charge. So it's not a carbonate. CO3 is not organic. Carbon oxide, CO, CO2, none of those are organic. And a carbide is not organic. So if there's just a bunch of C's together, that's C2. My handwriting's bad. That's not organic either. You're just looking for your CH bonds. Okay? Please pause the video if you need to finish writing that, and I'm going to get to my last page. So, what we need to be able to decipher, okay, and it's the point of today, is the question, is this organic or inorganic? So if we look at something, we need to know if it's organic or inorganic, And once we do that, we can dig deeper. So, an O double bonded with a C double bonded with an O. And remember, that double bond, all that means is that O is sharing two sets of electrons with C. So this is all that's saying, that there's a double bond here, a double bond there. There are two pairs of electrons. There's a pair of electrons for each bond line. So is this organic or inorganic? Well, my rules said it can't be a carbon oxide, and this is carbon dioxide, so it can't be. And plus, I don't see any CHs. So that's nope. But I would like you to write is inorganic. All right, number 2. We have two N's and an O. You should already kind of know the answer here. This is not a carbonite, a carbon dioxide, or a carbide. In fact, this doesn't even have a CH bond at all. So this is inorganic. What about this crap? You got 4 C's, all surrounded by 10 H's. All right, and the name for this would literally just be C4H10. We'll get into naming organic compounds a little later, but is this organic? Yes, it is. Because this is called a carbon chain, when a bunch of C's are linked together. Well, we said that C2, C3, C4, those carbides are not going to be organic. This is because it's surrounded by H bonds, and it's very stable. Number 4, we have a C double bonded with an O, and then the C is also combined with some H's. Is this organic or inorganic? Well, this kind of tells me no, but these kind of tell me yes. The answer lies in a CO, a carbon oxide, is not organic, but these H bonds make it organic. Those CH bonds do make it organic. And this is actually methanol, which you see in the ingredient list for a lot of stuff. Number 5, is this organic or inorganic? So this C with an O doesn't look too good, doesn't look too promising. I see some H's in here, so it looks like it is organic, except that the carbon is not bonded with the hydrogen. The carbon is bonded with the oxygen. So this is actually inorganic. Just because it has all the pieces doesn't mean it's right. So an inorganic compound is actually, this one's called carbonic acid. Now, disclaimer, there are a couple organic compounds that don't have hydrogen, okay? But they're so rare to be using in a problem or in class, we're just gonna go as if they are, okay? If there are exceptions, I'll let you know when it's time. Number 6, we have a C bonded with 3 H's and a hydroxide. Is this organic? Yep. And it is because of those. All right, last one, number 7. Look at that mess. This mess is actually going to become your friend because we're going to have to work with this quite a bit. This is called a ring, okay? And there are a lot of different types of rings in organic chemistry. I wrote the H's out here so you could see how they're bonded. So if you look at every C, it has 4 bonds. It's got, this one has 2. I'm sorry, let me write this out. This one has 2 here, 1 here, 1 here, 4 bonds. This one has 2 here, 1 here, 1 here, 4 bonds. This has got 2, 1, 2, 4. All of them are balanced, okay? And they go in a circle in a ring. How you would actually write this, it's crazy, and I'll explain how. What you do is you draw a hexagon, and then you draw the double bonds in the spots that you'd have them. So this is actually the symbol for a ring in chemistry, where you don't draw the C's, you don't draw the H's, you just draw the shape. And you can assume that each point is a carbon, and you can assume that they're all bonded with hydrogens. I'll explain that in depth tomorrow, but I thought I'd give you a quick taste of it. Is this organic? Yes, it is. It's made up of carbon and hydrogens, hydrocarbons, which is what they're called. So it is organic. Fantastic. So on Google Classroom, which I will have the link in the description of the video, and it's for a grade today. So join that classroom on Google Classroom today for a grade. And under today's lesson, I have something called homework 4-20 or 4/20. And there are 3 questions for homework. So that'll test Google Classroom and let me know if I'm even able to grade your stuff on there. And hopefully that is a little easier for you than writing it all out and then sending me a picture and then I have to zoom in on your picture, try to read your handwriting, all that jazz. I think this will streamline it a lot. So please jump on Google Classroom, answer those questions, and give me some feedback. Let me know what you guys think about it. And that should be it for today. So tomorrow we will be talking about skeletal structure forms in hydrocarbons. It's going to be good. Do not forget, your project is due not this Friday, but next Friday. Okay? If you have any questions on that, let me know and I will help you through it. If you haven't signed up for it yet, the link is still there on GroupMe.